directly to, was it to the software, right?
That's the weapons, yeah.
Yeah, it goes, this one's for the weapons, this one's for the drive. So practically, look, these two motors are geared and they're wired into these two motor controllers, which are wired directly to these batteries and into this receiver that are turned on by this switch over here. And then these are powered to these, the solenoid is powered to these two batteries, and all batteries are powered in parallel and turn on both of the weapon motors. They're both three horsepower motors that run at 6,000 RPMs. This bad boy runs about 6,000 RPMs, and the rear one runs at 6,000 RPMs.
Oh, those blades turn in the back then?
Yes.
Okay.
They're steel mill blades.
Mill cutters for use in mills.
So they do kind of more of a punch and scrape more than an actual cut, while these actually do a head-on cut. And because of the fact that they're segmented, the way it works actually punches through and actually it gouges. So when you actually compare the cuts from this and this is more of this type of cut, while this one's a very precise, fine, thin cut. When we were able to use these, you can see the blades actually cut through the steel like butter.
Oh, wow.
While as opposed to these, we're kind of able to push the robot out of the way. We used Spectrum technology because that's what the competition required. You can use any other type of RC control. We used nickel metal hydride and NiCads for the batteries. And however, they didn't last too long. They last probably 2 matches, and then we had to charge them right away. However,
this kind of batteries, you kind of have to know what rate to charge them, what amperage rates to charge them. So we were experimenting with that a lot, even on the day of the competition. We finally figured it out, like on the last couple of battles, how to charge them properly. But they're really good. They're small. They don't weigh a lot, but they put a lot of amps all at once.
Oh, okay.
And that's what we needed. We wanted as many amps as possible for those 3 minutes that the competition lasts. So we just want to give all those amps at once. We have some nice motor controllers that basically they can handle up to 120 amps, and basically they just accept a pulse width modulation signal. So you can just do that with the little receiver, send those pulses out with this guy, and then that's how you can control the motors via pulse width modulation. So kind of a simple design, but it works very well.
Deadly.
Do you think you're going to be able, if you were able to get sponsorship next year, would you do a different chassis?
Yes.
With a different type of design?
Definitely. Yeah, we would definitely need to get the manufacturers involved.
We're working on a bulldozer type of look.
Oh, okay.
For
The
defensive,
scoop on the front
exactly, for
end.
defensive purposes, and I want to call it bulldozer or hedgehog, and put these blades towards the rear.
How stupid.
So not only do we have a defensive part as our primary strategy, but if people are building us every day, just back it up and start seeing the sparks. So that's definitely something. We're hoping to maybe make it out of titanium, since it's lightweight, strong. However, it's not very economical.
Yeah, there's a lot of possibilities. In fact, we got back from the competition, and 4 hours later, I'm getting phone calls about their new design idea that they have. So yeah, they were very excited.
So are you going to be asking for sponsorship a lot earlier now? This
Yes.
year?
So if anybody knows, please.
Probably should. Now, other good things came out of it. We actually had $100 left,
Oh, did
believe
you?
it or not.
Okay.
But we already spent it on something else. And I'll tell you what that is.
Beer bust.
We actually, from this, another project came out. A different group of students that were more and more interested in programming type of thing. So we actually started a GPS-based robot. So basically, it's a robot that you put in the GPS coordinates, and it just goes there. At the same time, it'll have a lot of sensors. It'll be all-terrain, so it'll navigate to different terrains. And it's actually for a competition. It's called Robo Magellan. It's like a mini DARPA competition. Did you guys hear about the DARPA Grand Challenge? These
Yes.
vehicles, yeah.
Mhm.
These cars that were put out in Victorville in the desert.
Oh, yeah, yeah.
And they were to drive by themselves
Yes, yeah.
from point A to point B. Well, this is a mini challenge of that. Basically, we'll have like a field where there's trees and things like that. On the day of the competition, they'll tell you the GPS coordinates. And you just program that into your robot, and the robot has to go